Okay, here we go with, I guess, the first question on our notes, because I already did a video, but that's because I was just introducing it. So we got to the point where we were looking down onto Anthony's model of the pool and the border, and it kind of looked like this. It doesn't have all the details that the other one did on the video, but so you can see that inside of Anthony's model, he's got this 3x3 area right here, which is where the water is. This is not the part that we're really paying attention to. The part that we want to look at is the border, and they did tell us that there's a total of 16, but I do want you to see that there's a couple of ways to arrive at that number, because we are going to have to try to look for a pattern. So one thing that I like to do, one way you could look at this is if you were to count, so like, because it's a 3x3 square, actually let me write that. So it's a 3x3 square, and yeah, it's in highlighter, it's harder to see, but a 3x3 square. So you can see that we've got these 4 sides that are that 3 to make up the border. But then we've also got these additional corner pieces. Two, three, 4. So I want you to kind of see that pattern. And then it's asking us, though, to go back and sketch what Anthony's models would look like for the 2 smallest pools in this sequence. So up here, I said that this pool was a 3x3 pool because we had 3 tiles left to right and 3 tiles up and down. So for his next smallest pool, the next pool, we went down just 1 size. Instead of 3x3, we would make it a pool that was 2x2. So if I start with 2 of these, that would just be the pool. And then if we went to even the smallest pool, we can't go much smaller, but we could do a length side of 1 by 1, which would just be this. So we would still need to add the borders around it, which we will do in just a moment. But those would be the actual pools. So you might not realize it, but this entire situation that we are talking about right here with the pool border is actually a function in real life. And like I said, there's different ways that we can represent this. So the first way I'm going to show you is the numerical way, which is where we use numbers to represent the function. And in math, we might use a numerical representation so that we can turn it into a problem. So you can see down here, we've got a table that is set up where we've got on the left side, the length of the pool side in feet. So if we looked up here, we said that each one of these, well, because it was a yard, so each one of these is equal to 1 foot. So if we had the 3x3, that would be a length side of 3. Like this pool would be a 2x2. And this little one would be a length of 1, so 1 foot by 1 foot. So for the length side, we could just call these 1, 2, 3. But to find the tiles in the border, we would need to kind of come back up here to the top. So let's start with a 3x3 because we already looked at this one in the very beginning. So in a 3x3, we saw originally that there were those 3 on all 4 sides that kind of border that outer edge of the pool. So we've got 3 of these, and we've got 4 because we have 1, 2, 3, 4 of these. And then we've also got those corner pieces. So in addition to that, we've got to add in all 4 of these corner pieces. So we're going to add 4. So when we do 3 times 4, we get 12 plus 4, which is equal to 16. So we can put that in our chart down here. So for the 3x3, we end up with 16 total tiles that we need to create that entire border. And then for the 2x2 pool, we can break it down kind of the same way. So if we think about it in terms of how many pool tiles go here. And this is not the only way to break it down, it's just one of the ways. So if you think about, well, the length of the side is 2, but we've got 4 sides to it, so we've got 2 times 4. But then the thing we have to remember is to add in these 4 corner pieces also. So to add in this 1, 2, 3, and 4, we have to just add 4. So make that plus 4. So you get 8 plus 4, which makes this one 12. So, and you could count those up and double check, but you would find, this is messy, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So yeah, that is 12 tiles. So 12 would come in down here. And then when our pool side had a side length of just 1, again, we've got 4 sides where we can put it right up against the edge. So this time we've got 4 of those, but they're only 1. The side length is only 1. But then we would have to add in the 4 corners. So no matter how small we get, we're still going to always have 4 corners. And this is going to help us start to see a pattern. So if we've got 4 times 1, that's 4, plus 4 is going to make a total of 8. So is that 1, 2, 3, 4, 5, 6, 7, 8. So down here, we have 8. So while that was a little bit of work, we were able to come up with a numerical representation of that function.